I was late. How you guys all doing?
Not bad. Having a hard time adjusting to normal life.
Being back in class?
Yeah, having class, going to work every day. It's weird.
Yeah, no kidding. We got back from New York last night, and I am way behind. Not liking it.
Yeah, it's going to be probably a weekend in my little office, I'm thinking.
This is going to be a hard week. Is that what you guys are telling me?
No, not really. It's not supposed to be a terribly hard assignment. I haven't really dug into it yet, but others can maybe speak to it better than me.
Who else has dove in, I guess?
I've barely gotten started.
Yeah, I haven't even gone through all the lectures yet, so.
Yeah, I'm still watching Mondays right now.
Oh, okay. Okay, well, at least I'm not alone.
Yeah.
I already saw people were posting on the discussion, so.
Yeah, I think Emily and Tiffany are the keeners this week.
Okay. So, I got through the week before's lessons where he was going over quantitative genetics and all that. Does that come into play still, or is that just the early underpinnings? Where he's going over like P, 2P, or P squared, 2PQ, 2PQ, Q squared, and making up the matrices and all that kind of stuff. Or have we forgotten all that already?
No, yeah, I think that's part of it.
Okay, I started watching it and I'm like, oh, okay, I hope this is all makes sense eventually.
Yeah, like I'm still figuring out the tables, so I'm at like square one this week.
All right.
Hey everyone, how you doing?
All right.
Hello.
So, are there any questions this fine Thursday afternoon?
I'm in the process of getting everything organized. We just got back from New York last night, so I'm not your person today.
Well, welcome back.
A little bit of a talk on how to approach the random mating on the discussion board. Boris thought that we can just assume that it's already been done and that the populations are in equilibrium, so that it'd be easier to compute the frequencies. Is that the correct way to approach that?
Yeah, it's that if you just let it randomate for 10 generations, so start off with those 405 and let them randomate, keep the population size at 405, and so I don't go into any of the trouble with randomating a bunch of recombinant inbred lines. We just imagine that you start off with those 405 and you can start randomating. In corn, that would be an easy thing to do. In other species, that's a bit of a challenge. But anyway, yeah, that's the idea. Let it randomate, harvest the grain, pick out 400 randomly sample, 405 individual seeds, plant them, let them randomate again and just keep doing it for 10 generations. And if you're randomly mating, then you can make some reasonable assumptions about the allele frequencies and make reasonable assumptions about whether or not any of these loci are in pairwise equilibrium with each other and so forth. You don't have to worry about epistasis or linkage, essentially. The things that I didn't, in the genetic architecture of this trait, I didn't include epistasis anyway. And I don't think I included dominance. Maybe I did, but I don't think I did. So in case 1, we have D equals 0, and in case 2, we do have D equals 5 at each of the loci. Okay, so in case 2, you'll have to deal with dominance for that genetic architecture. Any other questions?
For questions 8 and 9, when looking at the average effect of an allele substitution, is that equation on page 10 of the quantitative genetic models document? Is that what that one is?
Don't know.
Look.
It's page 10 or not. What will be the average effect of each of the alleles at each of the loci in each of the random? So the average effect of an allele is not really the same thing as the average effect of an allele substitution.
Okay. Because I'm not sure how to go about calculating that, and haven't found it.
Now let's see. So the average effect of an allele is table 4.3, right? And class notes have average effect of an allele described on page 6, and on the average effect of an allele substitution is described on page 7.
Okay. All right, I get that now.
Okay. Jock, how was the trip to New York?
Very, very tiring, but very, very good.
Yeah. You went
Yeah, we
there-
took about 65. We took about 65 kids between band and choir, and we were up about. Well, we had to be on the bus by 7 in the morning or so, and then we were back. The earliest we were back is 10 o'clock at night.
And
So-
did they perform while they were there?
Yes, at
Where-
St. St. Paul the Apostles Cathedral
Okay.
down by Columbus Circle.
Yeah. They do
Yeah,
that.
right next door to Fordham University.
Ah, yeah. Okay. Very cool. Did the kids?
And then we went to lots of performances and things.
Yeah, yeah. You go to any Broadway shows?
Yeah, they went and saw Wicked, and we got to see the New York Philharmonic Orchestra. And I'm trying to remember everything. They had everything cram packed in there. New York or Times Square, Central Park,
Do it
all
all.
kinds of stuff.
Do it
Yep,
all.
exactly. We went down to
5
Harlem
Yeah.
to on Sunday to a Baptist church, kind of a revivalist Baptist church service. So, yep, it was good. I have a question? Did you go over the exam 2 on Tuesday, or has that been covered at all?
No, nobody's had any questions about it. You have a question about it?
Well, I did the worst on question number 5, and so I've read over the notes that you put in there, but I didn't know if you had any other observations or comments you might want to make about it to us.
It seemed like about a third of you struggled with question 5. Maybe closer to half. But people sort of had different types of struggles.
Okay.
Um,
Yeah, I know we, as kind of the group that was online, were kind of all over the place with number 5, and I think we thought that was the hardest one on the whole test.
yeah, it was. It was. Yeah, I think I cut and paste the correct answer in for all of those.
Yeah,
And if there's any questions about those, I'd be glad to help you out with it.
yeah, I took a look over it, and I guess it made sense what you were getting at, not getting far enough in depth as far as the analysis is what kind of the comment that you had made
Yeah,
on
from-
mine. So
Yeah. So a lot of people were going in the right direction, and then they sort of stopped, didn't finish. I guess maybe I sort of felt like that was the end of the analysis. But, and then there were some who didn't have a problem at all and went through it all, and there were some who seemed like they missed it altogether. So yeah, it was kind of all over the place. There wasn't any real consistency, but yeah, I agree it was the hardest among the questions. Overall, I think everybody. I mean, there were some people in class that got almost everything perfect. I had to really struggle to find anything to find any problems with. But I don't think anybody's really. I don't know if anybody got less than 85% of the stuff right. So almost everybody did really well.
as long as we're learning what we need to know, I guess that's
Yeah,
kind of what I'm aiming for.
yeah, I think that's right. Yeah, it made me feel fairly good, that those people were getting almost everything. They got all the basic concepts. Let's say and you all were not just doing calculations, you were interpreting results. So that made me feel pretty good.
Well, that's the only question that I had on exam 2.
Okay. Any other questions about the current applied learning activity or the general framework for understanding this theory? You know, if you sort of just get the idea for this theory, if you get the idea of putting these things into tables, kind of, I mean, these tables are not unlike you know, not unlike the Punnett squares. They're kind of very similar, and so if you sort of get to that point, then you can almost always work out the results. Now, for the people who are going on and taking the intermediate level of quantitative genetics, you're going to have to be able to do the algebra to derive, you know, what is a breeding value, what is the effect of an allele substitution. You'll have to be able to go through and do all the algebra. So most of the algebra steps I've included in the notes, but the next, as you come up on things, as you advance, you'll have to be able to derive these things. Because there's all kinds of nuanced differences. Let's say if you go to a polytoid, then things become, you just use the same approach, but you have to be careful with the algebra. So, anyway, that's, and the other thing to also always keep in mind is that this stuff is, these are just models, and they're, but you know, by definition, the model is wrong. It has turned out to be, these models have turned out to be very, very useful for us, the plant breeders, to make decisions about that these models aren't at all, we know now, they're not at all what's going on biologically. On the other hand, we haven't found any, nobody's really offered any other models that do a better job, that are more useful. But, you know, that could change. Okay, well, I'll let you all go then. I haven't paid any attention to the, and I should have, but I've been busy with something else. But I haven't paid any attention to the discussion. I'll get on the discussion board and take a look, see if there's any, you know, any problems. You know, people kind of wandering in any directions that need to be corrected. And with that, I'll see you later.
All right, thank you.
Sure, bye.
I'm also going to be heading out, you guys. I think I'm up to question 6 or 7. So if you have any questions, I can probably help up through there at least.
Yeah, I'm just orienting myself and going through the lectures, so I'm the last person here.
Yeah.
I'd highly recommend setting up tables and copy pasting and having them all autofill.
That's a good suggestion. I started making tables for question 1, and that's as far as I've got.
Yeah. Alrighty. Well, I want to get home, so.
Yep, that's fair. Have a good night.
Have a good night.
Yep, see ya. So is there any transformation that needs to take place before we do the tables? I'm just asking. As far as with the data set.
I don't think for the first question. I think those ones are pretty straightforward tables, like very similar. Well, not very similar. Like basically what is on the discussion board already.
All right.
From what I can see, that makes sense to me.
Yeah.
I'm literally just walking into this. So I'm really asking some dumb questions.
I can customize the file that I have so far. It doesn't matter who is most of them.
Oh, really?
No. I'm just making sure I have frequency value.
I was gonna say, I think mine came out pretty much the same as Emily's.
Okay.
If I can find it. No, I had originally had mine in a different order than her, and that threw me off.
Yeah, and like mine is similar because I followed the lead of what they had or what Emily and Tiffany had, but I was a bit confused as to where the because there's like the assigned binary number based on what the genotypic value is, but I didn't really understand where the frequency number was coming from.
Pull up what I have in just a second. So this is as far as I've gotten. So like the original frequency values, I just calculated off of what was actually observed in the data.
Oh, duh. Yeah, of course.
Oh, don't feel bad. I was feeling that way too.
Yeah, and then so like these values, I just multiplied the two together. I think it's that easy. I still need to do the means. I was trying to look at that equation and how we do those, but I haven't got that far.
The means?
I was thinking,
Yeah, that's what I was wondering if you guys have done yet.
yeah. So I was looking. I don't know if you can see the Word document. Can you see that?
No,
I just
it's
think
your
so.
Excel.
Okay, let me see if I can reshare. So I was looking at like this. Because I think to do the population mean, is this what he's asking for?
I
Where you-
think so.
Yeah, so like use those values from that table to calculate that, but I haven't done that yet.
Okay, I gotcha.
I guess maybe it's the genotypes. It's one of these. I haven't figured it out yet. I'm just getting into it. Tiffany, have you already done like expanding to the 3 loci?
Yes, but I'm not sure I did it correctly. I basically just put it all in one table. Is that what I'm supposed to do?
I mean, I think so. I mean, it just says extended. I think so.
So I can share what my dot table looks like. How do I share? So I just, I just basically put them all together.
Yeah, no, I think that makes sense. I was trying to look in the notes or the book or anything if it gave an example, but it doesn't. So that's all I was gonna do to expand it, just so it compared everything in one table.
And then I'd found this somewhere about the population mean, getting the midpoint homozygote, and then this plus this. So I'm not sure if I can't. I gotta look and see where the one that you were showing, if it looks the same or not.
Yeah, no, I just saw this one in the lecture. I was just watching for Monday. I think that seems. So the MH value, is that the value from the chart for each allele?
That is kind of what I was a little confused about. So I think for this first case it's 0, but I'm not sure about the second case where the
Okay,
numbers
because
are
it's
different.
sure because it's got the dominance.
Mhm.
Okay, I need to finish the lecture and actually.
So Tiffany, if you go down to your
Yes.
what he explained in office hours on Tuesday was he was thinking, this is Dr. Beavis, that you would have like marker 1, TT, and then below TT you would have marker 2, and then it would be you would split TT below it into 3 columns for the 3 different loci underneath it, and then you could just have marker 3 on the left. If that makes sense.
It does not, but
Yeah,
yeah.
I
Okay, awesome.
can draw it up quick. What you explained. Okay, so the way I took it is he'd want to. He was looking like this. If that makes sense. And then you'd still have M3 on the left side. Of GP, GA, whatever, and then AA. And then this would be your 27 cells in here.
Okay, and then how? I guess I'm confused at how I would calculate. Then
So I mean,
yeah,
you'd
I don't know how to calculate the cells from that.
So you'd basically go back and redo your frequencies. Either, I mean, you could do it off the raw data again. How many TT-GT do you have? How many TT-GA, and so on, right?
Exactly. So sorry, this would, if you know what I mean, this would actually be TT-GT. This would be TTA, and then you would just take those values from the one you did before for M1, M2, and then combine them with M3.
Oh, okay.
That's how we explained it. I don't know if your way works as well, but that's how Beavis mentioned it on Tuesday.
Oh, okay. No, that's good. Thank you.
Holy crap. I just took a look at your Excel file. Yeah, I'm way behind.
It's not that bad. It looks like a lot, but it's just...
Takes up lots of space.
Yeah.
Well, you already, for lack of a better word, merged your M1, M2, and M1, yeah, so that's from the exam. I get that. Is that all equal? I mean, that's all taken directly from the exam, all that work we did? Is that correct?
I think so.
Meaning it shouldn't be, the frequencies and everything should be the same as what we calculated out.
Mine don't match Emily's for some reason. I don't know if anybody can confirm that I'm doing this right. But like, for example, this is case 1, M1F2.
So I think the reason is she did 403 because she took out the parents.
Oh, okay.
Oh, that is right.
Yeah, I guess, do you include the parents or not?
I did. I guess he.
At first I did, but I remember one of our, was it in the exam? We took them out, but I can't
Yep.
remember.
Yeah, I had to.
In the exam, we took them out.
Yeah, my understanding is that you would remove them because if you have the parents in there, it's gonna like kind of, if you think of it as averages, it's not gonna make sense properly. If you have the parentals in there, you're gonna have to. Hopefully, if you pick your distant parents, they're gonna be really distant, where the progeny are gonna be more middle of the road.
Yeah, that makes sense. I can do that.
I just got the impression from the way that he talked that we included the parents, because he kept referring to it as 405.
That too, but I mean, if you make the assumption that you took them out, it probably doesn't matter. Or left them in. I mean,
He doesn't seem too picky if you're off just a little bit, as long as you can follow the trend.
yeah, I'll do it just to make sure I'm matching up with Emily and go from there.
Yeah. Well, if we're consistent, he'll just make sure that we know in the future that hey, parents matter.
I hope he's that understanding.
It really is.
Okay.
So how does everybody else feel about question 5 on the exam?
I didn't do better on that.
Yeah,
Yeah.
that was my worst, but
You just pasted in the red correction, and I'm not going to worry about it.
yeah.
I'm not too worried. I just wanted to know how. I think that we must have been the roughly half that had a problem with it. I'm guessing.
Yeah, I'm assuming whatever you guys got. Like, I can't find the document right now, but I'm sure I did quite similarly. Yeah, 7 out of 12.
Yeah, that's where I was too.
So I'm assuming, yeah, I just didn't go far enough. I started the analysis and gave up.
Hmm.
So I guess in that example where we expand to 3 and we put marker 1 and marker 2 together, for the genotypic values then, do we just add the value for like TT and AA together for all of those to get the actual genotypic value we're looking at?
I was using, like, maybe Zach, if you know, but I was using the value that I first got in that table. So the first table, when I put M1 and M2 together, I was using, so like for TTAA, I was using 0 and then 0.252 as my frequency. And then that's what I had. And then for TTAG, I was using 5 and then 0.03. And then I was going to combine it the way I was combining the other table with the M3. Does that make sense? I don't know if that's something you're doing.
Yeah, that's how I assumed that it would be done. Yep, I just haven't done it yet.
Okay. No, that's what I was thinking it would be. Just wanted to
Yeah.
check.
It's like you would take the M1, M2 already combined values and then just add it to them.
Sounds good.
Would someone be Tiffany or someone you mind sharing your Excel file again on your calculations for your
Yeah, sure.
tables?
Sure. A second.
We have emergency around with it.
Let me know if it seems off. Okay.
So what did you get 0.252 for TTAA? Yep, right there. Oh, your times.
Yeah, which is what I thought.
So what I'm getting. Sorry, go ahead.
No, that's what I thought I saw, but are you thinking it's different?
So what I thought it would be is you take that frequency just from the amount of TTAAs you would have if you combine markers 1 and 2 together.
Oh.
Does that make sense?
Mm-hmm.
So it'd be, there's 150 TTAAs when you combine M1, M2, and that frequency is point. Let's see here. Oh, my table's upside down here. So it's 0.372 is what I got for that.
Yeah, I see what you mean. I'm not sure.
Let me times the table you provided.
So I think.
Oh yeah, you're right. That's how it's being done in the notes. You're
Is
right.
it okay?
Yeah. My bad. Yeah. Yep. They're almost being done.
So I had a question from his lecture or from the office hours on Tuesday. He talked about summing the 3 integer values once you change your letters over to numbers to generate a GV. And then that's what you're going to use to create tables to compare the estimate means. And I've kind of been listening along to what you guys are doing, and I'm not sure where that ties in or if I'm just missing the connection.
I have no idea about that.
Yeah, I'm not really sure either. I just know that we're supposed to like create a sum on those numbers. So you have like your 3 marker points. So it would maybe end up, being a maximum of 15 or a minimum of minus 15 when you put them together. But I don't really know where that fits in. Like I have a screenshot of the lecture, but
Yeah, I have that included in my file here too for everything. I just don't know exactly where that fits in yet.
what it means.
Yeah, for like example, line 1 or whatever that first line is after the 2 parents, it's like -5, 5, -5, and that sum is -5.
Mm-hmm.
Yeah, and then 15, -5, and so on.
Okay, well, unfortunately, I have to run, but if anyone's online after work on Friday or on the weekend, I'll talk to you then.
All right. Have a good one.
See you
Talk
guys.
later. I will probably be on Saturday.
Oh, I think I will be. I know you guys were talking about this earlier, but for extending it across all three loci, you're multiplying all three of them together? Is that correct?
Yeah. So I think I have pretty much around that.
Okay. Okay, so I've got, let's see, I'm double checking my numbers too against yours just to be sure.
So here's this is case
M1M, I'm just going to check this first real fast. I'm looking at your M1, M2 frequencies and all that. Looks like we have the same numbers, we're doing things the same. Okay, so you went in and did M1, M2 combined and added M3. Okay, that's kind of what I was thinking of doing. But
yep, for example, this is those two times.
Yep. And then the same thing with doing the numbers, the 5 and the -5 and the 10, the whatever that is, the value, geometric value. There we go.
Put them together. Yep.
Yeah, looks good. Oh, you even added the the genotype on there too. Nice. I didn't think to do that. The TTGG, TCGG, so on and so forth.
Yeah, I didn't know if it'd come in handy later. I'm a visual guy. I think I have these. Good.
Now, my question is, I'm going to ask you this. Oh, you went on to the different question. I was going to say, why is it 20? I got it, because you went on to the next questions. That's it.
That's what happens. Yeah.
Now, did you get that? Were you able to get your formulas to work all the way across all of those, Zach?
Yeah, you just gotta use the dollar signs.
Okay, yeah. So,
They're fixed on certain rows.
so yeah, when you carried them over to the 3 locus one, what? Okay, so you're just doing dollar sign. Da, 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 da.
Yep.
Okay, well, yeah, but I meant for let's see, AS4. If you go up to the blue box, what do you have in there? A hard number or?
I just took it from I drew it from the first name. So that's TTGG. So I just took it from the TTGG.
Yep.
M1, M2.
Okay, you just equal that cell. Got it.
Yep. That way, if I had missed something else.
That's exactly what I was wondering.
Yeah. Formulas usually.
There isn't a quick way to do it, is there?
That's what I'm talking about.
Well, I'm going through and putting in each individual box into each individual cell. So I'm going to the TTGG genotypic value 10 and equals and then the cell and so on and so forth. Is there a quicker way to do it, or do you have to do each individual one? Does that make sense?
Yeah, just individuals.
Okay, that's what I gotta do.
So when you go here, though, you can just do, if you type the formula this way, for that line, you can just drag it across then. Drag it to the right, and it'll populate all these because the dollar sign has the row locked, and then this cell locked for this whole row. That makes sense.
Yeah, I got you with that. It was just more populating the genotypic value and the frequency numbers from the previous table into those boxes. That has to be done individually. Okay.
Yeah, that's what I did. There might be a better way to do it.
No, that's all right. It's a good way to build a table so that you've got it ready to go if you make any changes later on.
Yeah, definitely.
So just to check, so for your frequencies, when you combine M1 and M2, you're just using the tables that you created in question 1?
Yeah, for the 3 locus one?
Yeah.
Yeah, so for example, TTGG up here
Okay.
is straight from that table I started here. Right here.
Okay, because I had started to make it like off the actual population, and then mine was different. So off the actual data, like the raw data. Because if you just look at like all the TTGG, you get like 49 out of 405 or whatever.
I see. Yeah, that's what I was doing too. And then Tiffany looked at how table 4.7 was actually calculated, and they're just timesing the frequencies by each other instead of using like these numbers.
Okay.
Because that's how I originally had it set up. Was I was using these frequencies, just dividing each by the 403.
Yeah.
But that's not how table 4.7 was
Okay.
put together. It looks like. So.
Okay. Thanks.
Yeah. I think I got these 2 cases wrapped up. I'll save this and then put it on the discussion board if you guys want to see it.
Sure. So
Thanks.
you're through 1, 2, 3, and 4. Is that what I'm hearing?
Yeah.
Yeah, but the only thing I really need to do is just check my values against yours once I have this done. See if we. I'm pretty sure we're pretty equal, but always helps to double check.
Yep, for sure. All right, that's up there. I'm gonna take off for now. I'll see you. I'll be on Saturday, I think, as well for a bit.
Okay, thanks, Zach. Appreciate
Yeah.
it. How far are you?
Thanks.
How far are you digging down? Are you just gonna finish out or do this much and then go back on Saturday for more? So I'm assuming you're through 4, is what I'm saying.
Yeah, yep. And then he mentioned tonight that the random mating is just. We're just assuming that they're at equilibrium then, so I don't know. It sounds like it should be easier than it looks, but to like get question 5 started.
Yeah, okay. Sounds good. I should be able to get through 4 then tonight. That's a good chunk out of the way.
Okay.
Thanks.
Yep. Yeah, have a good night.
You too.
You too. Thanks.
I just opened up his file. Holy criminy, there's a lot in there.
Yeah, I'm still working on mine, but not nowhere near that far yet.
You have a good break?
Yeah, I didn't go anywhere exciting, but it was still nice not to have homework for a week.
Okay, Michelle, or any of you, for your ALA 13 document, do you have confidential across all the pages?
Yeah. He said he was supposed to be posting another one, but I haven't checked if he did. I think I had just pulled mine yesterday, and he still hadn't.
Yeah, I pulled mine just right before class hour or office hours, and it's still again. Okay.
Yeah.
Just wanted to check with that.
I haven't played too much to figure out how to get rid of it yet either.
I thought there was a simple way to do it, but I'm not going to worry about it.
Yeah.
Well, right now I'm through question 4 as well. I have almost exactly the same answers that Zach had. I think there's a little bit of rounding difference. Where are you at, Michelle?
I am just finishing 4 also.
Okay. So
I believe all my tables are done now.
I'm going to share what I have. You tell me if this is what you have for the question 3 and 4. Does that look the same for you?
So far, so good. Oh, mine's a different order. I have my GG on top. I was like, where's my number?
Okay.
Yeah, no, otherwise I think it looks right. Same thing
Okay,
as
so
I have.
I haven't gotten through all the class videos, so I'm sure it's in there. But okay, so we had the genotype value of 0 in the first question, question 2, and now we have a genotype value of 5. What does that say? So we go from 0 to 5. Our sum of frequencies is still the same. We haven't changed anything as far as that goes, obviously. But our genotype value is now higher.
I think he was talking something about dominance effect.
Okay.
Um,
If you don't know, it's okay. I guess I'm just asking.
yeah, no, I don't fully know off the top of my head yet. Still
Okay.
figuring it out.
Yeah.
I have something different. Why is that? So your value. Oh no, I see what I did. Never mind. I had pulled in. Why did that? Oh nope. Okay, I see what I did. Never mind.
You good?
Yours is good. Yep, yours is good. I didn't update the larger table when we extended. I don't have my marker 3 updated yet.
Oh, okay. Gotcha.
All right, are you actually going to go ahead and start on the second part?
I don't know if I can, is why I'm asking, because I haven't watched the class video.
Okay, I still need to finish yesterday's, so I don't know if that's what he covers. So, but I think I'll probably go and just watch that also.
Yeah, that's what I was
Figure it
going
all
to do. And then be ready for Saturday.
Sounds good.
All right. Well, have a good night. See you
Yeah.
Saturday.
You too. Bye.
Bye.